Hi, everyone. My name is Chris Laufra. I'm a software engineer at Uber Amsterdam. To basically understand a complex system. So switch to the slide. I used to work on Eclipse itself in a previous career at IBM. And for about a year, my role was to be performance analyst on Eclipse. And my goal was to make, or my mission was to make Eclipse run faster on IBM's internal Java virtual machine. So we had our own Java virtual machine done in a clean room environment. It's called J9. And it had some very specific characteristics that allowed us to do all kinds of optimizations that other VMs could not do. But I spent about a year investigating how to make Eclipse faster, and about 10 months of that, I would guess, is just basically spent in understanding what was happening inside of this application. And I thought at the time that this was a really complex application and really big. I'll reflect on that later. It is like with all software, everything grows slowly, and in the last 16, 17 years, Eclipse has gotten quite a bit bigger. But at the time, it was already hard to understand what was going on. So I spent, like I said, 10 months understanding and building very specific tools to help me navigate through how the application works internally before I could make any decisions on how to optimize. So my goal was to understand. So in general, like if you want to understand a complex software system, what you would do is you have an IDE and you can read all the source code. So if you try to read all the source code in our Android or our iOS repositories to find out how the Writer app works for these platforms, it will be a very long process to read all the code. So that doesn't work. So what you can do is you can run a profiler, which will tell you where most of the time goes, and that can be used or abused for also investigating what is actually happening inside the code, because it will basically tell you what code ran at what point in time, so you can extract some information from that. And if you know where the problem is, you can actually set a breakpoint, and then you can step through the code, and you can see all kinds of patterns occur. And usually you can set conditional breakpoints, like if an exception is thrown. So you could like piece back together what is happening. And then the third option is to do logging. So you instrument all your code, and all the interesting parts will generate some print statements or structured logs, preferably. And if it's a print line, it will go back into the IDE, so you can see things running live and get some feedback there. But usually these logs go into a storage system. And then there's a highly scalable database architecture query language that will let you get the metrics out and render it in the form of dashboards. So we use Grafana and Kibana inside of Uber. And this same observability platform basically is also used for detecting when things are anomalies, like when an outage is happening or when a certain thing takes too long. And I wrote the word panic there because if you are in on-call, this is usually what you feel when you get one of these alerts. This is, oh my God, what is happening? How do I solve it? And then you have complex runbooks that will help you deal with this particular anomaly in the thing that is happening. But these things are all sort of spread out, and there's no like really good way of figuring out if you're a new hire on a particular project, what does this thing do? And so my proposal is to actually say, like, let's find out another way, is to somehow figure out what is happening inside of this complex application. And in the case of Eclipse, this is a monolith. But the monolith is split up in about 100 features, which are product-like components, and about 1,200 plugins, which are building up these features. But the plugins themselves are also split up in different fragments, as they are called. And that's about 1,500 of them. So, and they all interact together. And it's almost a miracle that it works. It's like magically, they give you this editing experience. But there is structure behind all this madness. So if you do profiling or debugging, you don't see this structure. And so my goal is to take this very low level detail that you get and build up some structure so we as humans can see patterns and we can see surprising things, or we can see starting points for deeper investigation. So this is the background. So zooming in on Eclipse, this is not really relevant to Uber because we don't use Eclipse, not officially. There might be people actually using Eclipse. I've seen some individuals, but you're on your own. It's not a supported product. So why did I do Eclipse? Like I said in the beginning, I've worked on this. It's a big Java program, and I wanted to get familiar with Java again. I haven't used Java in a long time, so I just started playing with this. But the learnings that we get out of this, basically the summary is that I will show you how to find out more about Eclipse. And maybe this is an inspiration for you to figure out how to do this in your own tools. Like if there's a certain part that doesn't like instrument as well, like with Grafana or Kibana, and get dashboards out, but you want to show more of the structure. This might be an inspiration. That's my goal here. It's an open source project, so you can just download it and try it out for yourself. And the demos serve you to give a little bit of sort of examples of what it can do. So 3 demos. First of all, I will show you how many plugins there are. And I have Eclipse running here. So this is my outer Eclipse, if you want to call that. And you can use Eclipse to develop Eclipse. And then you basically have a launch configuration that says run Eclipse. So this is what you would normally do. There is already another Eclipse running. Yes, yeah. So run Eclipse again. And this will pop up Eclipse in a few seconds. Usually this is around 10 seconds on average. Depends on if your machine is warm or not. It keeps on jumping on my wrong monitor, so I'll keep dragging it in. It came up a little bit earlier than this. But now I have 2 Eclipses, so an outer and an inner. And if I want to like investigate what's going on inside of this thing, like there's this search dialog, for instance, and I can go to file search and I can do enable the regular expressions. If I ask you like which class is doing what, it's very hard for you to figure this out just by looking. So we're going to run Eclipse again, but now with Cacophonia enabled. And that's an agent that is attached to, let me try it again because not only coming at the wrong area, but it's also different timing. I think my machine is a little bit more busy. So why do you go there? Come here. Okay. So now what happened is that Eclipse is running as a Java application, as I said before. So when it's launching right now, there's a Java agent running that instruments every single method that I can find in every single plugin. And then the runtime gives this information to this big black window. And the current interpretation is to do some filtering. So I'm currently looking at feature level. You can see feature on the top here. If you can see this in there's a toggle here between feature, plugin, and fragment. So this is what I explained earlier, is the sort of the hierarchy and composition of abstractions inside the Eclipse platform. And let me see where my window ends. Right, here it is. That one actually did come up with the right one. So now I have the same thing as before. So I have an outer Eclipse, the white one, and then I have the inner Eclipse is the dark one. I gave it a different theme, so it's easier to recognize. But the third window shows me what's going on. So I said, like, I have features in here. The labels are a little bit hard to read, so I'll zoom in and make the font a little bit bigger. So hopefully you can see them now. So there are some yellow ones, myelin. There's some pink ones, RCP. And there are features in Eclipse. So these are not like individual classes. They're not even packages, not even like jar files. They're much higher. But there are a collection of different plugins that are shipped as a continuous element. So if you work on JDT, you would only be concerned with the JDT feature and not work on any of the core platforms. And this is how Eclipse allows itself to ship code and not be completely tied in. So in that respect, it really looks like a microservices architecture in that the individual features are independent of each other, and they survive by having a common interface with an API between the different plugins. The blue lines between things mean that they are related, and related means that they either have the same name in it. So in the case of myelin, because I put in a myelin filter here on top, it's recognized as something special that I'm currently interested in. If I remove myelin, it will actually not be colored and be less interesting. But that's something you can zoom in. So if you work on the myelin team, you probably want to see all the myelin plugins. So this is something you fill in. I also put in some filters for SWT, Workbench, RCP, console, and jobs, because those are attributes or elements in Eclipse that I know are interesting. So I know a little bit about Eclipse, so I could already put some domain knowledge in there in my search. So this is a very high level, so it's still hard to see what's going on, but if I click on anything here, you can see new things appear, and eventually, if nothing happens, they die and they go away. So very slowly, you go back to the things that are only currently active. So this is not just a standard graph. This one was really hard to write actually, because it's dynamic. It's constantly changing, and the weights are depending on. I want to show when things are happening. So the bright white light that is flickering means that a message was sent from one plugin to another, or in this case, one feature to another. So this goes really low, like from Java method level. Every method call, I compare where it comes from, where it goes to. And if they go to components which have a different class loader, that means that they have a different plugin. And then I can sort of like build up this abstraction layer. So we're at the highest layer now, so you can see these components like JDT interacting with something called E4 RCP, and there's an old RCP as well. So one thing we already learned here is that Eclipse has an evolution. Like they started out with RCP, and then at some point Eclipse 4 came out, and they made some mistakes in Eclipse 1, 2, 3, and they couldn't just undo these things because of like binary compatibility with the past. So they made a new plugin called E4 RCP that basically wraps around RCP and so on. So you can see some of this sort of this architectural inheritance show up in this picture already. And it's flickering. And another pattern you can see, like if you wait, you see like every 5 seconds or so, there's another flash happening. So I'll wait. There. So that was a little bit of a flash. This happens every 5 seconds. So if you observe this for a while, then you start to see these patterns happening. If I switch to plugins, it becomes more obvious that it happens. So I'm interested in SWT, so I'll put it in the corner here. I'm also interested in core jobs, so I'll put them in the other corner. So I can sort of like manipulate the graph a little bit, so to focus on different things. So myelin, I want to have on the left here, and it will like find its friends automatically. So here we can see there's interaction between JFace text and JDT core manipulation, and that's constantly beeping. So we have SWT and core jobs, and you can see it's almost like an event loop happening between JFace text and JDT manipulation. And then every 5 seconds, you can see this flash that involves everybody. So 2, 3, 4, 5, flash. So I'm interested what is happening here and why is it flashing. So I'll get to that in demo 3, but I'm already observing all these things happening. And if I go down one level to the lowest level of things, so this is like plugin fragments, it gets a bit overwhelming in the beginning. Like when you do anything with Eclipse, you change the selection or you change the cursor, basically, wherever it's pointing to, there's a selection listener that everybody subscribes to because they're all interested in being told. So there's like a Kafka engine running inside of Eclipse that has a publish and subscribe architecture. And that's what you see happening when you click in console. You see another flash happening. And then I click here and there's another flash happening. So all of these are like the publish and subscribe messages that are broadcasted across Eclipse. And that's what I said earlier. It's almost a miracle that this thing works because it's like it has this shared state, but at the same time, it tries to not interact directly with all these plugins. But still, they know all about each other. So if you want to figure out what's going on, like let's say you're a developer on Mylin and you're being told to change something in it. I think seeing something like this will give you a better idea of what's going on. Now, these are all the plugins that are happening here. These are the lowest kind, the fragments. So I'll do a start, which is almost similar to, or I'm running something. This is almost similar to starting up Eclipse with the amount of plugins that get involved. So this becomes overwhelming, right? You see too much information. So usually when I try to understand what's going on in Eclipse, I do it at the plugin level, which gives me a little bit better abstraction layers. And then, like I said, we can work with the filters here to highlight the ones that I'm interested in. If I'm interested in a particular one, I can move it around, and that's it. So there's a lot of other things happening. There's like, you saw this flash, you saw this 5-second thing, but it's hard to see that happening here somehow. Like the cursor is blinking, and if we wait a little bit, we'll see the pattern. So SWT is involved, of course, because SWT is the low-level rendering toolkit for Eclipse. So if you want to draw a cursor, you have to go to Eclipse, but also JDT is involved because if you're looking at Java code. JFace is involved, JFace text. And I'm already glancing some structure here, like there's layers here. SWT is lowest layer, and then we get like higher and higher. But I want to get notified when these things are happening. So let's go to Team 3. I have mute on here. And what I do is I select one of these plugins, like SWT. And now I can assign any instrument to that particular plugin. So I'll do a banjo. So this is banjo. And now when I make the cursor blink, it's actually playing a banjo. So this will give me some very concrete things that are happening. Now, SWT, like I said, is very, very, very popular. So maybe let's not do a banjo on Eclipse. But the other one I mentioned, like the one that runs every 5 seconds, is core jobs. So let's give that one an instrument. So then we can see every 5 seconds when something is happening. So you hear the pong there, and another one, and another one. So these are the pongs that are running every 5 seconds for some reason. And I'll give JDT core manipulation another one. I'm going to do a random one, like kind of. So that's. So there's a heartbeat of Eclipse happening here right now. If I click inside Eclipse, I hope you can actually hear this. I'll move my mic a little bit closer to my speakers. See if that works. I hope it didn't generate any echo because you're not supposed to move your mic too close to your speakers. But so I pre-made a selection of instruments in theme 2. That sounds a little bit more interesting, I think. Now, the question is, how useful is this? I think a practical use, like if you put this in an office and everybody has this on, it's not going to be, you're not going to be too popular. So maybe this is more like an art project, like trying to figure out like what's happening with like, giving you different signals. Okay, so that was the first demo. Let me clear here and let me turn off the music. Gets a bit distracting. So this gives a feeling for how many plugins there are. If we go back, I forgot to show you that. Go back to the outer Eclipse. There's some statistics that are presented here. And it shows you like when a plugin is loaded and when a class is loaded. And this will tell me that I had like 10,000 classes to bring up Eclipse. And it also told me that I have about 200 plugins. So this is currently to bring up Eclipse to a useful environment. You need 200 plugins and 10,000 classes. So that's the scale that we're talking about. And that's very hard to find out, right? Well, how would you normally get that number reliably? You have to log in and then you have to write SQL queries, and it's a lot more work. There's also a phase at point of startup, and then after startup, once the UI is showing, it's actually doing a lot more work in the background. And that's a trade-off, right? You want to get started as quickly as possible, but all the features that are sort of like luxury, you don't want to get bothered by. Okay, my presentation at the bottom, you would see a yellow bar, and I just noticed it myself. You see the yellow bar, and it's growing, so it means that I'm slowly running out of time, so let's speed up a little bit. So let me go to demo 2. Demo 2 is the console. And the question is, like, can we figure out what the console is doing? Like, what plugin implements it? Like, you're being told to fix the plugin, the console for some reason. So where do you get started? Like, how do you find out where this thing lives? So what we do here is, you see, I already ran it once. And here, when I run it again, let's see. There's a lot of things happening, and I wait until things slow down a bit. And then I move the mouse in. And when I move the mouse in, this UI console popped up here. So this is a good candidate for me now to figure out what's going on inside this particular area. So you can see a tab here says console, and then there's the output of the Java program is printed there. And there are a couple buttons here that do something. For instance, if I click on the pin one, the console is now pinned. So this particular one will not be replaced by anything else until I unpin it and then gets unpinned. So let's figure out what's happening when I do that. So I right mouse click on UI and it says inspect Orc Eclipse UI console. And earlier I told you that the agent instruments everything. So you get every single method call, enter and leave event. And now what it's doing at the bottom here, it's actually, let me clear this thing and do something in the console. So now I'm doing something in the console and I'm moving the mouse. Let me go down so it scrolls. Go to the bottom. See, it's printing a lot of things. But this is a full trace of all the functions that are happening. I have to unlock it. Let's see. Yeah, so now it's scrolling. Good. So let's run it again. And I'm working on the console, remember that? So I really want to find out all the things that are happening. So I get a lot of details here, but that's okay because that's actually what I want right now. And eventually when this slows down and I start pinning, then I can see in my console here, pin. I'll just search for something like pin. And then all of a sudden you see this class appear, the still scrolling. Let's stop the scrolling. So it's called pin console action update and run. So these are the functions that are running whenever I press this pin thing. So if I hover here, it will say like pin console. And now what I can do is I can actually go there. So to the run function, for instance, by clicking on it. And this will now open my outer Eclipse. Remember the one that I'm using to develop the inner Eclipse with. And here's the run function. So I can set a breakpoint. I already did that. So if I stop Eclipse now and start it again in debug mode, I can actually stop at the point when you click on the pin function. And it is coming up in the background. Not in the background, but in a different monitor. So here the essence is that you can use visualization to figure out what's going on, but if you do the right kind of instrumentation, then it will tell you exactly what code ran. You can then visit the code, you can set a breakpoint, and you then can start debugging it. So startup is a bit slower. You will notice if you saw the original Eclipse took about 10 seconds, this will take around 40 seconds. And it makes sense because every single function that I have is replaced by 3, at least. Because the enter and leave also have to do some logic to figure out if it's worth sending the event over a socket to another process that then renders it. So if you look at the bottom here, it says that there have been 15 million calls. And that's only the calls that I instrumented. So I don't instrument the Java runtime. So this is only Eclipse calls. And that's about 8 million plugin calls. That's the scale that explains why it takes a little longer to run. But I'm going to run this thing again. So I'm going to trigger the pin console action. And when I click on this, it should actually trigger the breakpoint. And here we go. So now I can step into the code and I can do investigation of what is actually happening in this function. I can step out, it runs with event. I can see the stack trace here. Oh, it's coming from this lambda here, event table. I can see all the way down to the core platform where this particular function ran. And now I have a chance to actually fix this because this should not be null. This should be some other constant, whatever. So with some visualization, you can get information about what's executing inside. And if you connect it all up and you go back to the IDE, you can make changes and then run it again. That's extremely powerful, of course. So let me run it again, see if it continues. And I'm going to try and reuse this one and not start up again. Wait some time. So that was the console. You could see I was just watching. I set a filter, so I know the console is involved. I didn't set sound this time, but through inspection, I can see all the method tracing happening and then I can see the debug. So now the third one is everybody needs a job. So that job that was running every 5 seconds, which is it? So let's go back to our visualization and go to plugin. It's easier to see that job running. And if I unmute, you can actually hear it. So that big sound is when the job runs. So this one here. So for this one, I did some really customized visualization. So I know about the domain, I know about jobs, and I overlay them in our visualization here by selecting jobs. And this is now overlaid here. This is a little bit hard to see, so I'll zoom in on the text. So you can see all the individual jobs that are executing. So every 5 seconds, like 40, 45, 55, 0, 0, 5, you can see this activity monitor job and the open notification job. And if you look to the right, it's the class that is actually the job that is responsible for that activity. And I mentioned Myelin before, and Myelin is involved in almost everything. So that is an interesting plugin to actually inspect if I'm working on Eclipse. Okay, so I'll turn off the sound. That concludes the demo. So it basically gave you an idea of how you can use visualization to very quickly understand a complex network of nodes and how they interact with each other and the different layers. So you have fragments, plugins, and features, but also how you can like discover what code is interesting to set a breakpoint in and make a change into and then try again. So the way that works is that there's an agent running, and it comes with, in Java, if you register an agent, you get notified of each individual method call. And normally you use this for profiling, so you make a custom profiler, or for automated logging, so you can do some analysis on whenever a sensitive API is involved, for instance. In my case, I just instrumented everything by doing bytecode instrumentation. So every function gets rewritten to a new function by inserting method enter and leave. And I use JavaSys as the library. It sort of works, but not entirely. So if I have some spare time left over, I'll try a different instrumentation library, like ASM for ASM. Tends to work a little bit better. JavaSys still falls over for certain patterns in Eclipse, but it works well enough for this demo so far. At runtime, when this instrumented method runs, it then calls a library in Cacophonia Java, which has an open socket and it sends messages to UI.java. If this is in production and you're running in the cloud, for instance, you would use what's called Java MX Beans, which have this process standardized. I reinvented the world here because I wanted to have really low layer, like no overhead in my socket connection, and very well controlled. This is only 10 lines of Java, so in this case it paid off to just write that by hand, so I could actually control the performance because I'm instrumenting everything, so I cannot deal with any overhead here. And then the UI is a different process. You have to, because if you try to do this from within Eclipse, you're constantly fighting to be on the UI thread. And you're going to inevitably run into performance issues with the visualization. So this is how it works. And then there's some meta visualizations, which are also interesting, I think. So if we look at this graph here, I said before, it's quite hard. It was quite hard to build. Like it's dynamic, it's growing all the time. And there's different forces happening. The blue ones are related, so they want to be close together. The white ones are like, there's something happening right now. And then the yellow ones mean, or the red ones mean, they've done something in the past. So they have some relationship. And each one has a different force. And I can also move things around and then fixate them. And you can see the blue ones are sort of contracting together. Now, debugging this was really hard. And I had some cases where suddenly when I dragged core here, it would jump over here in the top left corner. And because this is so dynamic and chaotic, you can't really set a breakpoint and then figure out what's happening. I almost need a visualization on my visualization system to figure out what's going on. So what I did is I overlaid this with a debug. And this tells me all the forces that are happening. in this thing right now. So if I take SWT and pull it here, you will see SWT receives this force in this direction. There's a red arrow here. Let me zoom in. So on SWT, you can see this arrow going in the bottom right, and that has a force of between 0 and 29 with an angle of 31 degrees. And what that tells me is that like I could tell like sort of like why are they moving together and why are they staying apart. So that helps, but still didn't really help me. So I had to write some in my source code here. If I go to the code for Cacophonia itself, this is the package that implements the graph. I have an edge, I have a graph itself, I have nodes, some abstractions of that. And we also have a node test. So this is like a unit test for all the different things that you can do with a node. So that catches the error conditions, those are the edge conditions. But I have to predict what the error would be. And with anomalies, with sort of like surprising things, you cannot predict, and you can't really capture that with something like a unit test. So what I wrote is some visualizations on the tool itself. And let me find my. So for vectors, I did this. So I have to bring it back to the right monitor. So this is basically, you could see this as a unit test for vectors, but it's visual. And I'm doing two scenarios where the angle is fixed and then I rotate. And then if you add two angles together, like the red and the blue one, you produce the orange one. And the orange one should always be in between the red and the blue. And in the case of 90 degrees, you actually use Pythagoras for calculating. So it's a square, b squared equals c squared. So you can calculate both the angle and the length. But we as humans, we can see patterns here. Like everything works fine. And I had one case when x is less than 0 and y is less than 0, that it went in the wrong direction. And if you don't have a unit test for that particular case, then you will never tell. But because I have this very specific visualization, I could see it happening right away. So this is just a meta level visualization. And I have one for graph as well, where I have, like you do with unit tests, you have a predefined set of inputs, and you have some predefined expectation of what's happening. So this is a very well-defined number of nodes, and I send a message between two nodes once at a time. So now I can keep track of some of them. So you can see these two here, and this is all looking good. I can play with the different forces in the system. So repel more, repel less. I can increase the call force. So now you can see they actually grow together. And I can also do the history one. So now it will be really emphasizing things growing together. So I can play with the different parameters and the algorithm much easier here. And like before, you can write a unit test for this, but it's hard to predict what the outcome would be. So many different ideas why visualization is good. It tells you what's going on inside the program. And if you can tie this back to the original source code and make changes more easily, that works in a big system. But even for small ones, like the vector is only 20 lines of Java code. And you wouldn't think that it would be so hard to write, but adding up vectors for me was very hard. And writing this little visualization I wasted like 2 days before just trying to figure out what the edge case was. And then when I ran the visualization, I saw it right away. So this is also an opportunity for your own work. Like you could figure out different ways of showing the individual components of your system, how they interact. So earlier I mentioned that I did this before in 2004. At the time, to bring up Eclipse, it's like 26 plugins. It took like 100 megabytes of main memory. Today, we're getting much closer to a gigabyte. I think that's exaggerated gigabyte, but 200 plugins is at least, right? I haven't seen it grown to 1 gig yet. It's more like half a gig. So I should update this slightly. There's a different economy of scale here happening. So the summary, the goal here is not to remember things or memorize things, but to really understand. And for understanding, you need visualization. And I've just given you some examples. I hope they were useful. And I'm looking at the clock right now. I set the timer for 45, so he's blinking. So I actually have 15 minutes left for discussion.